compute-intensive training has been key, a perfect job for GPUs. But as the models mature, more and more inference is needed.
Now post-training techniques have been introduced to make these models very capable. Now, to extract the value, you need to go to inference. And so that's how people actually use AI, is through inference.
Inference can happen on less powerful chips programmed for more specific tasks. Enter custom ASICs, application-specific integrated circuits, and every major cloud provider designing their own. While a GPU is like a Swiss Army knife, able to do many kinds of parallel math for different AI workloads, think of an ASIC like a single-purpose tool, very efficient and fast, but hardwired to do the exact math for one type of job.
They can be much, much more efficient in running those workloads, but when you specialize them, you can't change them once they're already carved into silicon. And so there's a trade-off in terms of flexibility.
While NVIDIA GPUs cost upwards of $40,000 and can be hard to get, startups rely on them because it's even more costly to make your own custom ASIC for AI.
It is hugely expensive, costs minimum tens and often hundreds of millions of dollars.
But for the biggest cloud providers who can't afford them, custom ASICs pay off because they're more power efficient and reduce reliance on NVIDIA.
They want to bring cost of AI down. They want to have a little bit more control over the workloads that they build. But at the same time, they're going to continue to work very closely with NVIDIA, with AMD, because they also need the capacity.
Google was the first to make a custom ASIC for AI acceleration, coining the term Tensor Processing Unit when its first ASIC came out in 2015. The TPU also helped lead to the invention of the Transformer at Google in 2017, the architecture powering almost all modern AI. We got a tour at Google's chip lab in 2024.
There's actually 4 chips inside there. It's connected, actually 2 of those are connected to a host machine that has CPUs in it. And then all these colorful cables are actually linking together all of the Trillium chips to work as one large supercomputer.
A decade after the first TPU, Google just released Ironwood, its 7th generation, and with it a big deal with Anthropic to train its LLM Claude on up to 1 million TPUs.
Some people even think that they're technically on par or even superior to NVIDIA, but traditionally Google has only used them for in-house purposes. There's a lot of speculation that in the longer run, Google might open up access to TPUs more broadly.
Amazon Web Services was the next cloud provider to design its own AI chips, after acquiring Israeli chip startup Annapurna Labs in 2015, where Ron Diamant has worked since day one. AWS announced Inferentia in 2018 and launched Trainium in 2022, now approaching its 3rd generation. Think of Trainium like a cluster of workshops with many small, flexible tensor engines, while Google's TPU is like one big factory conveyor belt with one big rigid grid specialized for matrix math.
The difference between the names is quite telling, but over time we've seen that Trainium chips can serve both inference and training workloads quite well. On average, we see that Trainium provides between 30 and 40% better price performance compared to other hardware vendors in AWS.
In October, we went to northern Indiana for the first on-camera tour of Amazon's biggest AI data center, where Anthropic is training its models on 500,000 Trainium 2 chips.
Behind me right now, they are working on delivering these towers. 2 of them together is going to make up one Ultra server. And what's especially interesting is there are no NVIDIA GPUs in there.
Although AWS is filling its other data centers with lots of NVIDIA GPUs to feed hungry AI customers like OpenAI.
The investment they're making on our platform is still significant, and significantly more than you're seeing even in some of the upcoming ASIC deployments.
And we can't talk about custom ASICs without mentioning Broadcom and its top competitor Marvell, which act as back-end partners so clients don't have to hire full silicon teams to handle everything in-house.
All of the big hyperscalers actually that have ASIC programs partner with at least one chip design company, Broadcom being the most important, which helps provide the IP and the know-how and the networking. And so you've seen Broadcom in particular be one of the biggest beneficiaries of the AI boom.
Broadcom helped build Google's TPUs. Meta's training and inference accelerator launched in 2023, and now a huge new deal to help OpenAI build its own custom ASICs starting in 2026.
We see Broadcom winning 70, maybe even 80% of this market. We see this market accelerating, at a mid-double-digit CAGR over the next 5 years.
Microsoft is also getting into the ASIC game, hoping to primarily use its own Maya chips in its Azure data centers. Although little has been revealed since plans were announced in 2023, and its next Maya chip is facing delays. Intel has its own Gaudi line of custom ASICs for AI. Tesla has announced an ASIC, and Qualcomm is breaking into data center chips with the AI 200. Of course, there's also a slew of startups going all in on custom AI chips too, like Cerebras, making huge full-wafer AI chips, and Grok, with inference-focused language processing units. The final